VENSIM that we just discussed in class. I'm here in the Dropbox directory under Lecture 7 for Handy. I'm going to fire up the VENSIM model for Handy. And let's see it popping up. And I'll walk you through the general structure of the model. And for some reason it's taking a little bit long, but I guess there it is. So I'm going to expand it some to show the model in its entirety. And so you can see here that the model's got 4 stocks. Starting with the upper left, the elite population, the commoner population is the second stock, nature, and the wealth. So those are the 4 stocks. And you can see there's a lot of auxiliary variables going around the model, lots of arrows. So probably the easiest thing to do is to look at the structure of this model, is to focus our attention on each of the stocks and see what the dynamics are. So let's take a look at the elite population stock. So the elite population, if we just click on the equation here, now we'll see what goes into the elite population, and we'll get the dialog box. And we'll be able to see that, and you can see that there's it's running a little bit slow today. I don't know what's going on, but so here we go. It's the elite population. It's a level variable. It's a stock. It's got units of people, abbreviated PPL, and it's equal to the births of the elite minus the death of the elites, E births minus E deaths, and it's got an initial value, which is the initial elite population. Okay. So if you look at the elite population here, you have the initial elite population, and if you click on that, we'll see the value. And this model, I believe, has a value of just a single person to start with as elite. Yeah, single person. Okay. See in contrast what we started the commoners with. The births that appear here are essentially driven by a beta E, which is the birth rate and the elite population, and that has units of people per year, and that's why the E births, and the beta E here is a parameter that's externally specified, and at this point I think I have a default value, which is the one that we discussed in the lecture, and it's 0.03 per year. Okay, so these are essentially elite population born per year per unit elite population. Okay, so that's how the births are constructed. Let's walk over to the deaths of elite population. If you look at that, you're going to see that it's going to be driven by an alpha E coefficient that appears there, and the elite population. So it's a product of those two. Again, people per year as units. No surprises there. Now the alpha E, it's remember that these death rates in the Handy model are given by this relationship that is it's got a maximum and a minimum, an alpha capital M and an alpha little m, so the death rates are between these two values, and the variation between these two is a straight line, and that straight line is modulated by the relationship between a minimum wealth and the existing wealth in the system, the ratio of those two, and the inequality factor to account for the presence of elites in this case, and let's see how how those shake out in the equation, and you'll see that the equation for alpha E, and that's going to be very similar for alpha C, which is for the commoners. It's this auxiliary variable. It's got units of 1 per year, and this here is a statement that that transforms here. So this if statement. So this is basically saying, if the accumulated wealth is less than the minimum divided by the inequality factor, then you get it's basically alpha m minus kappa times the alpha m minus the alpha m min times the wealth. Okay, so that's the equation that appears that we discussed in the class. So look at the syntax and make sure you understand how this if if then else statements are used in VENSIM to understand. It's fairly straightforward. So that essentially assembles the elite population. The commoner population is assembled in much of a similar fashion. You have commoner births and commoner deaths, and I'll go through this a little bit quicker. There's a beta C, okay, and there's an initial commoner population. I want to take a look at that just to show you in contrast what that is compared to the initial elite population. If you recall, the initial elite population was 1. The commoners are 100, okay? And it's got units of people. So you start with 100 commoners and 1 elite, and then you watch the system, move over time. Now let's look at how one feature that this model has is the use of shadow variables. You see that the minimum wealth threshold that's in the model is calculated using essentially this rho, which is the minimum per capita wealth that is required for subsistence. The inequality factors. So you see these shaded variables are essentially variables that are elsewhere in the model, but that are replicated there, and you can see the shadow variable here. That's used very, very cleverly to avoid, having, these long arrows that will kind of get in the middle of the variable. So that's how they're used. So you can see kappa inequality. Here's a shadow. Here's a shadow. And then it's actually here as a variable. So this is the main location, and then it's shadowed here and here. Let's take a look at the right-hand side of the model, and we have the nature stock. The nature stock is fed by initial nature, once that is fed, the initial nature gets depleted by production, okay, and it gets regenerated. Also, the nature regeneration is driven by a regeneration coefficient gamma and the carrying capacity. If you actually look at the equation box for nature regeneration right here, let's take a look at that. You'll see that equation for essentially what's the third equation in the VENSIM model that we saw. So you can see here that the regeneration is gamma times y times lambda minus y, and that's essentially the regeneration equation that we saw. Now if you look at the equation for nature, you get that essentially it is regenerated as we just saw, and it gets depleted with the minus sign for production, and production feeds the wealth, okay? If you look at the production term, you will see that the production is the delta production factor times the commoner population times nature. And this is basically meant to imply that the commoners are the ones depleting, in this model, depleting the nature stock to produce wealth. Okay, so if you look at wealth now as a stock, you can see that wealth it gets generated or deposited. The positive side to it is production, the depletion of nature, and it gets consumed by the commoners and by the elites. Another interesting thing is that the initial wealth in this model is 0, so this starts with 0 wealth. So it takes for some commoners to start depleting nature to produce some wealth, and then that wealth starts enabling future growth of population. So the wealth gets produced and it gets consumed by 2. Let's take a look at the consumption, and I'll pick for example, the consumption of commoners. You can start with that, and let's see how that looks. And what you'll see is that the consumption, as we saw in the equations, are equal to a, a commoner consumption per capita times the commoner population. Okay, now the commoner consumption per capita appears here, and that's the one that is driven by the minimum of the accumulated wealth divided by W min, or 1. And you will notice that we introduced here a little max just to make sure that you don't get negative wealths in the system, and if you do, you sort of ignore them, and then multiply by the subsistence salary per capita. And if you look at the elite consumption per capita, it's fairly similar to that. It only has an additional factor, which is the inequality, kappa, multiplying it. So here's the same thing, it's the same minimum times the subsistence salary S times kappa. Okay. And notice the units throughout, just that they're consistent. I made an effort to make sure that was the case. And you can see here the clever placement of the shadow variable, so you don't you start not running. Otherwise, these arrows. One thing when you assemble these increasingly complex models, it's useful to keep these arrows short, so you keep the variables close to where they interact. So that's why the shadow variable feature of VENSIM, it's fairly useful. So that's pretty much it. That's in terms of the structure of the model, again, wealth then kicks back into the alpha C, into the alpha E through the threshold between W and W min, and again here you have W min as a shadow variable, and we can just take this model and run it, and let's see, it's running. And for some reason, it's giving me this warning. I think it's running correctly. I can't see any error in the results. And then we can go to Control Panel and have a graph that I set up, which is the handy state variables. It's called. I'll display that. And this is the graph that's in the lecture presentation that I showed you. Let me just expand it a little bit. Okay, there we go. And so this graph essentially shows the results that we saw in the presentation. Essentially what happens in this handy scenario is it's non-sustainable, so you can see that all variables die out. What happens is that you have the 4 stocks. You have the commoner population in blue right here, and it starts. It starts and then it starts to produce. As it starts to produce by consuming nature, it brings it down. It enables a little bit later the growth of the elite population. Eventually, they both are able to grow significantly at the expense of nature. So nature, runs out, and in doing so, they produce wealth. But what happens is that once nature goes away, the existing population of commoners and elites deplete the wealth. They eventually die away as well. So this is an unsustainable scenario that you can see. And let me get out of this. Oops, sorry, came back. And I think the other thing I wanted to mention here is that one of the things that we didn't look at in the value was this delta production factor. As we saw in the lecture, the delta has the value of delta has an impact in terms of enabling more or less population growth or maximizing the carrying capacity for population. In this case, the production factor that we used is one of the scenarios that's run in the handy paper. The value is, let's see the dialog box, I believe it's 10 to the minus 4. Yes, here it is. 10 to the minus 4 per year per people. So that's the value that's there. And this is essentially what we ran is one of the sub-scenarios under scenario 3 in the handy paper. And I believe that this depletion rate is much higher than the optimal. So what's happening here is that we're running a scenario in which the population is consuming way too much. The commoners are, in order to produce wealth, to sustain themselves and the elites, the delta is too high, and eventually you drive nature away. You drive it down too fast. It's not able to regenerate at a pace that's fast enough. So you outpace the nature regeneration, and eventually, the whole system collapses. So this is a classical example, but I want you to play around with this model. There is a sustainable scenario. One of the sub scenarios under scenario 3 in the handy paper that we discussed in class does allow for a coexistence of elites and commoners and nature and wealth in a sustainable fashion. So that's one scenario you can run, and you can tweak around some more of the parameters, particularly play around with this delta factor and see what happens if you tweak it up and down, and see how that goes. So I'll leave it at that, and I hope you enjoy this video, and that you're able to play around with some parameters. Post your results on our Facebook page, and along with some discussion, so we know what you did. Okay, thank you very much. I'll stop here.